Hello everyone, welcome to my talk. I'm Laixin from Shanghai Tech University. I will present my work, RoleSeer, Understanding Informal Social Role Changes in MMORPGs via Visual Analytics. Massive Multiplayer Online Role-Playing Games, or MMORPG, is a typical online game. It creates virtual communities that support heterogeneous social roles. Social roles are determined by gameplay interaction, namely a virtual social network. We categorize social roles into the formal role and informal role. Formal role is predefined by game designer, obvious, and is implicitly ascribed to the people holding the roles, like career, game leader, etc. Whereas informal roles are not well defined and unspoken, like the offline friends, multiple accounts belonging to one player, core player, etc. So why do we need informal roles? Because they implicitly influence the development of the virtual communities, and the virtual community may also change players' informal roles. For example, when a newbie could have proper guidance from a veteran, he or she are more possible to become a core player. Therefore, identifying the informal roles and understanding their subtle change are critical for designing sociable mechanisms. Studies on social network and visualization can be divided into three categories: social network analysis in MMORPGs, graph lantern representations, and dynamic graph visualization. Although these studies provide helpful guidance for designing the social mechanisms in games, they have little discussion about the undefined social roles, which is the informal roles, not to mention their existence, interconversion, and evolution. The RoleSeer system is divided into two parts: backend engine and front-end visualization. To infer potential informal roles, we propose a lantern representation of each node, or each player, to capture structural identity in the dynamic evolving network. Specifically, we first leverage struct and SIGCHI to extract the node embedding in each dynamic network respectively. Then, we attach transient module to align embeddings between the continuous networks. After that, we use the dimensionality reduction technique, TISNI, to project the node embedding into a two-dimensional space, and cluster the projections using X-means. The resulting clusters are then considered as informal role candidates. An informal role cluster should capture diverse temporal information, maintain the structural identity within the cluster, and maximize the inter-class difference. We hence adopt sex graph matrix and calculate the intra-class similarity and inter-class similarity according to these two formulas. Our experiment leverages three dynamic networks constructed by 6-hour data, and the baseline models are dynamic AERN and end-to-end dynamic graph embedding model, and diachronic node embedding, which uses node-to-vec to produce node embedding with alignment techniques. We first draw a box plot of players' time step along each cluster. For A and B methods, the time distribution within each cluster is concentrated, implying they do not maintain the diversity of temporal information, while our methods shows fairly diversity at most clusters. For the interclass similarity, it's observed that most interclass matrices of our methods are higher than those in the other two methods, especially degree and average centrality. For the intra-cluster similarity, although DNE wins in most matrices, our method still shows a comparable performance. The visualization system consists of 6 views. In role transition overview, we design a glyph to represent an informal role. A cluster stands for an informal role, and the inside radar chart indicates the graph matrix. And the color on the outside ring indicates the color at the next time step, which is a role change. Moreover, users could hover the glyph to observe another radar chart of the transition target and make comparison. In matrix statistic view, we design a glyph to include the graph matrix to describe the informal roles, and in game statistics to facilitate users to find the shared game characteristics of informal roles. Specifically, the left side draws in-game matrix by a special box plot along the circles, where the field frame denotes the range and the hollow arc represents the interquartile range. The right side shows the distribution of abstract graph matrix on axis. The information of an individual player is also drawn by a link and a polygon. After clicking two informal roles in the role transition view, the role transition projection projects the graph embedding results of players within selected informal role cluster. The left or right space shows all nodes of the selected cluster. The highlighted nodes indicates the player of role change. The middle column shows the matrix variation when role change occurs. The purple line indicates the matrix variation of a specific player. The event interaction wheel shows players' event sequence, where the size of a glyph indicates the number of occurred events and the color of a glyph indicates an event type. The individual interaction wheel visualizes how an ego interacts with 1-degree alters over the course of his or her gaming process. The event distribution is showed by stacked bars, and the interaction among players is supported by a storyline-based metaphor. The red rectangle indicates the current events corresponding to the selected player. We evaluate RoleSeer with 2 case studies: user study with 12 participants and interviews with domain experts. We use a video demo to illustrate case study 1.
An expert looks at the overall information to find out all transition percentages are low and other metrics vary within a reasonable range. After that, the expert concludes that the game generally runs stably. The expert then moves to the role transition overview, and after expanding 2 snapshots, he locates 2 informal roles involving the thickest transition between the first and second snapshot. The second informal role have a bigger radar chart, thus he implies it is more important. After clicking 2 glyphs, the metric statistic, and the role transition projection update. The advantage in graded combat score illustrates the players within second informal role have more combat experiences and capabilities. The glyph of the second informal role is a bit ahead of the first glyph and furthermore, the expert wants to explore the subcluster and role transition projection. He first lassos a set of dots comprising transition players, then an event interactive view. A collection of nodes have similar appearance. Then he clicks one of them, and the corresponding dots and role transition projection is connected by deep purple links, and the corresponding narrative glyph updates an individual interactive view, which facilitates the expert to inspect the metric changes caused by role change, and to understand the event sequence leading to role change. Especially, the expert implies that this players within a community know each other outside this game regarding their nicknames. He also finds that the closeness drops significantly and a player, P, is offline. Therefore, he proposes a hypothesis that the absence of the player P leads to the drop of the ego's closeness. By exploring in another subcluster and role transition projection similarly, he identifies another alter of the community. The metric change of this alter is similar to the previous ego, and in its individual interaction view, the same player P was offline when the shift in closeness metric occurs. Thus, the expert concludes that the player P played the informal role that preserves community closeness.
In user study, we evaluate our system in 2 aspects: workflow effectiveness and convenience of visual design. Participants were asked to explore the system in order to answer the set questions. In general, our system was highly rated. In future work, we plan to include more graph matrices to describe informal role. Thanks for listening.